Welcome back to Maths with Mr. Duffield. I am the aforementioned Mr. Duffield, and the first thing I must pass on is an apology. It's been a couple of weeks really since I sat down to do some maths videos for you, and it's partly because of the reports that we've been writing in the last few weeks, but it's also part and parcel of the entire lockdown. Lots of things to do. Not all of them are to do with work, actually. And getting things in order and the priorities straight is important for the well-being. So even as I am doing this math support work for you, please be reminded that obviously there are priorities in life. There are things that are important. I lose sight of that all the time. I know how easy it can be to do so. Please make the most of the extra time that you do have to focus on what is important. For instance, this question, which is the next episode in my ongoing GCSE past paper review for my UF and my GE. It's a circle theorems question. Points L, M and N are points on a circle. QMT is a tangent to the circle at point M. Find the size of angle NOM. NOM. So that's relating to this angle here. All right, and for that one first, we need to recognize that this kind of crossed over kind of X shape is just a slightly different version of something that you might have seen before. The thing that I've told my classes in the past is not an arrowhead. It is not an arrowhead, this, but it does tell you, it does reveal a certain circle theorem, that this angle is always half of this angle here. Okay? The angle at the center is double the angle at the circumference, or alternatively, the angle at the circumference is half the angle at the center. So by that logic, this angle here is just a version of this shape that's been dragged over a little bit to another point. And if you see that, what we see here is that it ends up being a kind of X sort of shape, the one that we have here. Just if you visualize dragging that point across, eventually this line will overlap this line, and then you'll see that this is what results. As a result, this angle here, NOM, it's got to be double 27, 54. And we can write angles at the center are double angles at the circumference. Now, you might be looking at that and you might be saying, well, sir, of course that, I've done enough practice of circle theorems to know that that's going to be the case for that part A. But part B is a bit trickier. We're looking for angle NMQ. In other words, NMQ, this angle here, this one here, the angle between the tangent and this little chord here. How on earth do I work that out? Well, I need to remember that the angle between a tangent and the chord is always going to be equal to any angle that's made, that's subtended by that chord. Any angle that opens out to the ends of this chord within this circle is going to be the same size as the angle between this tangent and this chord. I know that that's a bit of a mouthful. I appreciate that that's a bit weird. I know, but it's an important circle theorem. It's probably the trickiest one. It's called the alternate segment theorem. Okay, so that's what we write in our reason, and hopefully you can see on the diagram that there's another angle that's provided to us that opens up to the ends of this chord, and that's this one here, 27. So the angle is 27 degrees in size, and it is that because of the alternate segment theorem. The angle between this tangent and this chord is the same as the angle on one side of the circle that opens out to touch the ends of that chord. Okay? That's a bit of a mouthful to explain, but it's for IGCSE marks regardless. I hope that helps you and that you're doing well. Stay positive, stay motivated, stay determined. Hold fast to that which is good, and I will talk to you very soon.